Okay, so how is everyone today? Good? Good. All right. So we've been talking about lines, and we've still got plenty of stuff to say about lines. But just to retread the ground just a little bit, we had said that concerning lines, they can be broken into the following, slope categories. So four of them. So here's examples for each one of the categories. So for the slope categories, the way that they're defined is as follows. So for each line, select two different points. And then with those 2 points, what we're going to do is make a rectangle by traveling from one point to the other. But we're going to say that when we travel, we always have to travel in the first direction first, and then in the second direction second. So like from here, the first direction is the horizontal one, and the second direction is the vertical one. So from here, we have to travel horizontally first. So we travel, like that, so to the right, and then from there, we have to travel down. And the name that we gave to those measures is from last time. We called this one delta x, and we called this one delta y. Now, because we didn't write a scale, there's not like grid lines on there. You can't tell me the exact value of delta x and delta y, so you can't read it off. But you can tell me if they're negative or positive. So this particular delta x, is it negative or positive? It's positive. It's positive because it's pointing to the right, and that's in agreement with the world. And this particular delta y, is it negative or positive? Negative, because it's pointing down, which is in disagreement with the world. So positive and negative. That's if we start from there. But what if we started from there instead? So again, the rule is that you have to travel in the first direction first. So that means we have to make our horizontal movement first. So horizontally we travel like this, and then we'd have to travel like this. So we could say, well, this could be delta x, and that could be delta y. But notice that if we say that this is delta x, then would this delta x be negative or positive? It'd be negative, opposite of that one. And this delta y, would it be negative or positive? It'd be positive, opposite of that one. Okay, but what will be the case is that whichever route you choose, one of them is going to be negative, and the other one's going to be positive. Okay. Now, if you stir this, then you would be going in a clockwise direction. Okay, and the world is right-handed by convention, but clockwise is left-handed. It's in agreement with your left hand. So that means that concerning this, the slope, in this case, would be negative. All right. So similarly here. So we'll deal with this one. So we'll say, all right, we would travel first horizontally, then vertically. And you know, in this case, delta x would be positive and delta y would be positive. So they're both positive. If we started from here, first we travel horizontally, then vertically. In this case, delta x is negative and delta y is negative. So in this case, with delta x and delta y, they're either both positive or they are both negative. Okay, and if we did the stirring, in this direction, then this would be counterclockwise, which is right-handed. So that means that the slope here is going to be positive. Now, these other two, these are sort of the interesting cases, and they can be understood in terms of rectangles like following. So imagine that I could grab hold of this line and wiggle it, and you would see that rectangle sort of wiggling to compensate. And then if I take it and grab it and turn it all the way until the line's horizontal, like that, then the result will be a rectangle that has no height. It'd be a squished rectangle, no height. Similarly, if I take this line and wiggle it and watch the rectangle wiggle in response, if I take the line and turn it all the way until it's vertical, that would be like this, and that is like a rectangle that's been squished like that, so it has no base. So concerning delta x's and delta y's, for this one, because you don't travel left and right at all, this one would have delta x is 0, because you don't travel left and right. What would this one have? It would have delta y is 0, because you don't travel up and down. All right. So now, I want to fill in this these two blanks, but I'm going to put it on pause for just a second. So I want to fill in this blank and this blank. So this slope we said was negative, this one positive, and we want to fill in these blanks. But to help you, we said what it was last time, but to help you see why it must be the way we said, remember that we said that the slope formula we said that if you have a line and you choose 2 points, 2 different points, then you can calculate delta x and delta y. And we said that the formula for the slope is delta y over delta x, rise over run. So now that means that slope is a fraction. It's this much divided by that much. And everything that you knew about arithmetic still applies when we're talking about these lines. And before we were talking about the lines, it was not allowed to divide by 0, and it is also not allowed to divide by 0 now. So, notice that in this case, when delta x is 0, if there's going to be a slope, that would mean we're dividing by 0. Numerically. So what's our name for this kind of slope? Undefined. It had to be that way because we want the slope to be reckoned like this. And what's the slope going to be here for this one? 0. Because it's not okay to have 0 in the denominator, in the low position, but it's fine to have 0 in the numerator. So like if you have a pizza, pizzas are usually cut into 8 pieces. So initially, you have 8/8 of a pizza, and then you eat one slice and you have 7/8 of a pizza. You get down to one slice, you have 1/8 of a pizza, you eat that last slice, then you have 0/8 of a pizza. So it's fine for 0 to be in the numerator. Good. So, that being the case, we can have some examples. That point and that point, and maybe this point and that point. So the question is, find the slope. All right. So you know, because there's grid marks, that means that we can find the exact value of the slope. But even before we do that, you should be able to look at these and say which category they're going to fall into. So what kind of slope, what's the slope category of this one? Negative. And this one? Very good. So from here, we could calculate the slope in the following way. We could say, you know, 1, 2, 3, 4, 5, like so. So, you know, because we were traveling horizontally and because we got 5, that means delta x has something to do with 5. So should it be negative 5 or positive 5? Positive 5. Positive 5 because we were moving to the right, which is with the world. Okay, then from here we travel 1, 2. So because we were traveling vertically, we're talking about delta y. And because it was 2, that means delta y is either negative 2 or positive 2. So which one is it? Negative 2. Negative 2 because we were going down, the opposite of the world. But, you know, if you started at this other point, you know, and wanted to travel to that one, then you could say, okay, I'll go 1, 2, 3, 4, 5. So that would be, you know, because we're traveling horizontally, that's talking about delta x. And because we said 5, it's one of the 5s. So is this, you know, this one, 1, 2, 3, 4, 5, is that negative 5 or positive 5? Negative 5. And then from here we travel 1, 2, going up. So that would be delta y is positive 2, because we were going up. So now observe that, you know, depending on where you started, you either got 5 and negative 2, or you got negative 5 and positive 2. That's a little concerning because apparently it's different. But remember that the formula for slope is that ratio. So the slope is delta y over delta x. So either one you happen to choose, it's either, you either found negative 2 over 5, or you found 2 over negative 5. And of course, those are the same value. All right. So then, how about this case? So what will we get for delta x? Suppose that we start at this point. How much left and right do we have to travel? 0. Right. So that's enough for us to say, oh, this must be the vertical case. So that tells us that the slope is undefined. Any question about this? So generally speaking, you know, when you have 2 points, and you're trying to figure this thing out. So this is a 2-dimensional problem. If we were in a 3-dimensional problem, then the rule would be, well, first we travel in the first direction, then we travel in the second direction, then we travel in the third direction. Good. So now what we want is a formula, so we can figure out the equation for a line. So the main one for us is going to be the point-slope formula. Point-slope formula for the equation of a line. So concerning the slope categories, the 4 slope categories, negative, 0, positive, and undefined, we're going to break those into 2 groups by saying, well, the slope is either defined or it isn't. So we're going to have 2 cases here. So the case 1, that's going to be the slope is defined. Visually, you might understand this to be the non-vertical case. So what's given to us is a situation like this. So we've got a line. And what's known is that it goes through a point, point x1, y1. So I'll mark out some point here. So how about this one? So we know it goes through that point. And we also know that it does so with slope m. So it's going through that point, and we know that it's doing so with slope m. And what we want is a formula. We want a formula for the equation of the line. So I could say let xy be another point on the line. So that means I'll take the drawing and I'll add one more point. How about this one? xy. So some other point. And in the same way that we've done so many times, now I can do the same rectangle travel, delta x and delta y. So I'll say, okay, this is delta x here, and this is delta y. Now, what we know, what we're given, is that whatever that delta x and that delta y is, we know that delta y divided by delta x is m. We know that's true because the line has slope m. And now I'm going to take this equation, delta y over delta x, and I'm going to multiply both sides by delta x. Now, it's remember that you can multiply both sides of an equation by a number as long as that number is not what? Not 0. So I know this delta x is not 0 because I specifically said that we're in the non-vertical case, and xy is another different point. So delta x is definitely not 0. So this is definitely okay that we did this. So doing that, what's the new left-hand side?
Delta y.
Just delta y, because the delta x's cancel. Okay, now it's just a matter of writing down, of figuring out what delta x and delta y are. So delta x, that's the difference in the x's. So I'll write that's, that x minus that x. So x minus x1. And what's delta y? Very good. And so now I'll take those and plug them into this formula. And there we have it. So this is a formula that you're supposed to, from now on, know and love, memorize. So it's called the point-slope formula, because this is the equation of the line, of the non-vertical line, that goes through the point x1, y1 with slope m. Very good. So the second case is much easier. That is to say, the slope is undefined. And visually, this is the vertical case. So now we're given so it's going through some point x1, y1, and it does this with undefined slope, so slope is undefined. And now the question is well, what's the equation of this line? The equation of the line is just x equal to whatever the x coordinate is. X is x1. So it usually helps to have a couple of examples. So for example, so there's a particular line, and suppose that this point right here is like something like 1, 3. Okay. If that's 1, 3, then what about this point right here? Say, if that's 3, height 3, then what is probably the coordinates of that point? 1, 2. Right. Because it's horizontally in the same position. So the x coordinate is still 1, but it's a little bit lower, so now this is 2. And this point right here might be like 1, 1. And that point right there might be 1, 0. Right? But do you observe that all those points that we choose, all of the x coordinates are 1. Every single one of them. So the equation of this line is just x is 1. It's all the points where that is true. Similarly, so this might be like -2, 3, something like that. So what's the equation of this line? X is -2. All right, easy enough. So there's no calculation to do here. So this is like all there is to say for this one. But now we need to do one of these, and an example one of these so that we can do a calculation. So something like that. We got a nice line there. The request is find the equation of the line. Find the equation of the line and solve for y. Well, at this point, we only have one. We only have one way to go, because we've just got this one formula. So evidently, it has something to do with that. But then, what's the name of this formula? The point-slope formula. It's named after the information that you need, a point and a slope. So, in some sense, what was given is 2 points. And we don't have a formula called the point-point formula. We have a formula called the point-slope formula. So, we need a point and a slope. So we're given more than 1 point, so that's fine. So what we really need is a slope. Well, we know how to find that. So that would, doing this, that'd be something like, 1, 2, 3, 4, 5. So that's telling us that delta x is 5 because we're going in the positive direction, and 1, 2. So delta y is 2, positive 2, because we were going in the positive direction. So a point and the slope, we just determined that the slope is little m equal to 2 over 5. And what point are we supposed to use? So we want to write, x1, y1 is equal to something, to whatever point we're supposed to use. What point are we supposed to use? It doesn't matter. So, we were given, it sort of looks like we were given 2 points, and I suppose that's true, but, really we were given infinitely many points. But 2 of them have been marked out, So, it doesn't matter which one you choose. It won't matter. But it's important for me to point this out for you because, maybe you could practice this and get good at it and not really realize that you were just arbitrarily choosing a point, and then on the quiz you might suddenly realize, wait a second, I have a choice. Which one am I supposed to choose? And then you might get in a panic. It doesn't matter which one you choose. So because it doesn't matter which one you choose, that means that you can choose sort of whichever one you think would make your life easiest. So for my taste, for my money, I think that this one would make our lives easiest because both coordinates are positive, right? I think that would make my life the easiest. But you could use that one too. But you just have to plug in negative values, and then you'd have to deal with that. Okay. So I'll choose that one, 2, 1. But do understand that either would have been fine. So now, for the equation, well, it's just copy that formula down. So y minus y1 is m multiplied by x minus x1. And now it's just a matter of plugging stuff in. So y minus 1 is 2/5 multiplied by x minus 2. So y minus 1 is 2/5 x minus 4/5. So y is 2/5 x minus 4/5 plus 1, moving that 1 over. And then combining this, so negative 4/5 and then plus 1. Well, 1 is 5/5. So negative 4/5 plus 5/5. There's 1/5 left over. So, any question about that one? All right. Good. So there's all kinds of ways to ask you to find the equation of a line. One way is remember. Let's see. Did we do it? I can't remember. I'll have to think about that. But at any rate, there's lots of ways that we could do it. So one way would be something like I could give you a circle, 2 circles, right? And then I could give you the diameters of the circles, and then you could find the centers of those circles, and I could say find the line that passes through the centers of these 2 circles. So that's like a lot of, you gotta chug along, do a lot of work, but you could do it. It'd be the same, but all that it's doing is that instead of giving you 2 points directly, is that I say, well, one of the points is the center of this circle, and the other point is the center of that circle. Yeah, so you'd have to, you know, bunch of work to get the job done. All right. So another vocabulary word that we need is intercept. So given a graph, and remember what's meant by graph is a graph is the set of points that satisfy some equation. The set of points where when you plug them into an equation and the result is true. So given a graph, a point in the graph with x equal to 0 is called a y-intercept. So a point in the graph with x equal to 0 is called a y-intercept, and similarly, a point in the graph with y equal to 0 is called an x-intercept. So notice that that they're a little bit kind of, you know, seemingly flip-flopped. So, you know, x equal to 0 is a y-intercept, and y equal to 0 is an x-intercept. The reason that's the case is that, you know, recall concerning any axes. So recall that, you know, if we take the standard names for these axes, calling the horizontal one x and the vertical one y, you know, notice that the y-axis itself is a vertical line, right? Which means, because it's a vertical line, like one of these. So, like the equation of this line is x is 1, and the equation of that line is x is -2. So, you know, if I take this line and move it over a little bit, that might be like x is 3. And if I move it over here, that might be like x is -5. And what if I put it right on the y-axis? So what's the equation of the y-axis? That's x equal to 0. That's its equation. What's the equation of the x-axis? Y is 0. Similarly. So as a result, the reason for the flip-flop in the name is because notice that the y-intercept is when x is 0, and the the y-axis is when x is 0, and the x-axis is when y is 0. So here's some examples. So something simple first. So maybe like this. So we want to know concerning the graph, concerning the red. Is there any point where the x coordinate is 0? That's equivalent to asking, concerning the graph, is there anywhere where we're touching the y-axis? And the answer is, yeah, right here. So that's the y-intercept. Is there any place where we're touching the x-axis? Yeah, right here. So that's an x-intercept. Okay. But the definition just says graph. It doesn't say line. So it doesn't have to be specifically a line. It can be any crazy old thing you like. So it could be something like something like this, say. Something crazy. And then it's just where are we crossing the x-axis or not, and where are we crossing the y-axis or not. So there's an x-intercept, there's an x-intercept, there, and there is a y-intercept. So you can have more than one. How about this? Does this one have an x-intercept? Yeah, right here. How about a y-intercept? There isn't one. And I guess one more, just to make sure that it's clear, is that we could have just like a circle or something, right there. So how many intercepts does it have? Yeah, none of any kind. Okay, that's possible. No intercepts, and maybe one more. Let's make sure this part is clear, because it's easy to overlook this possibility. Is this is an x-intercept. This is a y-intercept. And then, are there any other intercepts? Yeah. Yeah, so touching is enough. So that's also an x-intercept. It doesn't have to cross. So it can, just bounce off of it. Good. Any question about it? All right. So now we're in position to talk about another formula for a line. So the name of this formula is called the slope Slope-Intercept formula for the equation of a line. So, you know, the previous formula that we have is called the point-slope formula. It's called the point-slope formula because that's the information that you have. And this one's called the slope-intercept formula because, well, the information we're going to have is a slope and an intercept. And then, you know, there's a few other formulas like that you can have, like you might have both intercepts. Well, that one's called the intercept-intercept formula. Okay, because, you know, we're not trying to be too creative here, but with the naming. But one thing I wish I could get everyone to agree to, all the math people and textbook authors and things like that, is really a better name for this one would be slope y-intercept formula, because there's two kinds of intercepts, and in this case we're talking about the y-intercept. All right, so then here's what we're given. Here's what we're given. We're given, well, a slope and an intercept. So we're told that, you know, there's a line and it has a slope m. We'll denote it slope by little m. And when we were doing the point-slope formula, I said, you know, I indicated that we had a point and it was about right there. But we're still going to have a point, but in this case, the specific point that we're given is the y-intercept. So we're specifically given that point. All right, so this is the point that we have. Now, because there's not a scale on these axes, you can't tell me the exact location of that point. But you can tell me one of the coordinates of that point. Which coordinate do you know and what's its value? Yeah, we know that x is 0. So we know that that's 0, and this we don't know its value, but we know it's not 0 because it's not on the origin. And in this specific picture, because it's up high, we know that it would be positive instead of, if it was down here, it'd be negative. So the typical name for this is B. So I'll just write B. So that's what we're given. And to find the formula, we can just use the previous formula. We can say, well, the point that we know is x1, y1 equal to 0b. And we are given the slope is little m. And as a result, we can just use the formula from the previous one. So y minus y1 is m multiplied by x minus x1. And just plug in the stuff that we know. So, you know, it reads y minus b is m multiplied by x minus 0. Of course, x minus 0 is just x. And so this can be written as y is mx plus b. And here's another formula that we're supposed to memorize now. So it's called the slope-intercept formula because when you read it off, that m there, that's the slope, and b, that's the y coordinate of the y-intercept. All right. So qualitatively speaking, you know, we could ask about the following. So if I draw several examples. So examples like that. And then I could ask, you know, about m and about b. Now, because there's no scale, you can't tell me the exact value, but there's enough for you to tell me, you know, if they're negative, 0, or positive. So m, the slope, in this case, negative, 0, or positive? Negative. Okay. B, in this case? Negative. Now, how can you see that it's negative? Very good. So that's the y-intercept, and because it's below the origin, that means that b is negative. So how about the slope of this one? Still negative. So the slope's negative. And how about b? It's going to be positive. So why is it positive? Right, because there's the y-intercept, and it's above the origin. All right. What's the slope for this one? 0. Because it's horizontal. And how about the y-intercept? It's positive. All right. What's the slope for this one? Undefined. And what about b? There isn't one. So you could just write undefined or something like that. So in a rigorous math class, you'd want to say that there isn't one. You say it doesn't exist. All right. So now I have a question. So we go back a couple pages and we look at this one. So this was a couple pages ago, but I'm covering that bit up. We came to this answer. Y is 2/5 x plus 1/5. So in terms of, you know, y is mx plus b, do you observe that this here is m and is positive, and this here is b and is positive? So the fact that m is positive means that the line should be going, you know, like that. And the fact that b is positive means that it should have an intercept that's above the origin. And specifically, it's saying that the intercept should be at 1/5. That's where it should be. So now let's look at it and see if that agrees with what was drawn. So we said that the formula from just copying it from down there, that y is 2/5 x plus 1/5. So does the slope 2/5 agree with just the general direction in the picture? Yeah, right. And then, you know, I just freehanded it. I didn't get out a ruler or anything and try to make it real super accurate. But you can see that right there is the y-intercept, right there. And is it conceivable that is a 5th? Does that seem right? Yeah, that could be a 5th. And I could get out a ruler and do it real careful. But you know, if we made an error in this calculation somehow, like when we were doing this negative 4/5 plus 1, and you know, some, you know, brain cramp happened, and then we wrote negative 1/5. You know, so you know, if we had written this down, 2/5 x minus 1/5, then what I'm saying is that you should be able to look at your answer and look at the drawing and say, no, something is not right. These are not in agreement. They're not in agreement because if this was right, if this was correct, then the y-intercept should be below the origin. Should be below. But it's clear that it's a little bit above the origin. So it's not that one. I must have made an arithmetic mistake. You go fish it out and say, oh, it's supposed to be positive 1/5. Right? Good. All right. So that's all that we have for today. I hope you have a wonderful weekend.